Hi, everyone. What we're going to be working on today is something called double angle problems. So basically what this has to do with is if we know the sine or cosine or tangent really of an angle and we wanted to calculate the sine, cosine, or tangent of twice that angle. Now, for this lesson, I'm just going to focus on sine and cosine, but I do want you to be aware that there is an equation, a formula for tangent also. But in this particular lesson, we're just going to be looking at sine and cosine double angle identities. So I have up here at the top the formula. So you're going to need to write those down. And we're going to work through just one problem. And that's all it's going to take for you to know how to do these. Because it really is all about following these formulas. So if you look at the first example that I have here, we have a problem where we're given that the sine of an angle is 2 over 5. And remember, what that means is 2 is the opposite side, 5 is the hypotenuse. And that angle is in the first quadrant. And what we have to do is we have to find the exact value of the sine of twice that angle and the cosine of twice that angle. Oops. Come on. Okay. So the first thing that I would suggest is we go ahead and draw a little sketch of this. So if we sketch this out, we're going to be in the first quadrant. We're going to have a sine, which is the opposite side, or the height, which is 2, and the hypotenuse, which is 5. Of course, our right angle is right there, and I can't quite draw it because it's too small, but that would be our theta. So the first thing we usually have to calculate is the adjacent side, which would be our cosine. So for the adjacent side, we'll take the square root of the hypotenuse squared minus the opposite side squared, right? That's just Pythagorean theorem, kind of jumping to the chase. And we get that the adjacent side is square root of 21. So that's how long that side is. So now we're just going to write our formula and substitute the values in. And that'll give us the exact value of twice the sine of whatever this angle is right here. So our formula is 2 times the sine of theta times the cosine of theta. We will have 2 times the sine of theta was given to us, but even looking at the diagram, we can see it's 2 over 5, what I have in pink there. Okay. And the cosine of theta would be the adjacent side, which is root 21 over 5. So what I just, underlined in green. And all we're going to do is multiply straight across. So 2 by 2 by root 21 is 4 root 21. The denominator, 5 by 5, is 25. So that is the sine of twice this angle right here. Okay, so pretty simple. Just follow the formula. For cosine of 2 theta, as you saw, we have 3 options. What I'd like to do is work through all 3 options with you on this problem, just so that you can see that all 3 will give us the same answer. But for the problems that you have to do later on, you just have to pick one. And sometimes like one's easier than the other to do for one reason or another. So just keep that in mind. So the first formula I'm going to use will be cosine of 2 theta equals cosine squared of theta minus sine squared of theta. Okay, so now we already know cosine of theta because we have it right here. So let's think about this. Root 21 over 5 squared minus, and again, we have sine of theta, which is 2 over 5, 2 over 5 squared. So let's calculate that out. Root 21 squared is just 21. 5 squared is 25. Minus 2 squared is 4. 5 squared is 25. We subtract those values and we find out that the cosine of twice the angle that we see here is 17 over 25. So now again, I'm going to do this problem with you using the 2 other formulas. We should get the same answer. If we don't get the same answer, we did something wrong. So the cosine of 2 theta equals, so now we're going to use the formula 2 times the cosine squared of theta minus 1. So seeing that we already did this, we have the cosine squared of theta here. So 2 times this, 2 times 21 over 25, would be 42 over 25. And the formula calls for us to subtract 1. But, if we're subtracting, we have a fraction. We're going to multiply this by 25 over 25. And lo and behold, look what we get. 17 out of 25. Same thing we got here, we got here. So it really shows you that these two formulas will give us the same value. And again, sometimes people lean toward one formula versus another. Sometimes one's easier because you've already calculated a value. It's kind of, just depends on the problem. Okay, so third formula for the cosine of 2 theta is 1 minus 2 times the sine squared of theta. And once again, we got the sine squared of theta up here, so we don't really have to do that again. So we'll have 1 minus 2 times 4 is 8 over 25. Kind of been here before. We want to multiply this by 25 over 25. So we can subtract. And oh my goodness, it actually works. Look at that, 17 over 25. Same thing we got here and the same thing we got here. So what that shows is it really doesn't matter which one of these formulas you use. You should get the same answer, assuming you do the math right. Okay, so 2 pretty straightforward formulas for you that will allow us to find the sine and cosine of 2 theta when we know theta. That's it. Have a wonderful day, everybody. See you soon.